I can't tell you how thrilled I am to be here at the National Building Museum. I'm a huge admirer and supporter of this institution, and we couldn't be at a better place for this exhibition and this event, and working with the team here has just been extraordinary. So I'll try to share a little bit of that story as well. But let's dive right in. Many of their canonical spaces, such as the Oyster Bar and Grand Central Terminal, may be known to you, or the Ellis Island, the Great Registry Hall, which was built almost 100 years ago. And yet, these projects are still largely unknown to the American public, and we still have a long way to go to understand their work. For example, we have very few details right now about this project. There's much more research to be done and to be learned about. But it's extraordinary that an immigrant family who arrived only a few decades earlier found themselves building the great ceiling of Ellis Island in the 19-teens. And it really epitomizes the United States as a land of opportunity, as well as the unsung heroes who helped make our country great. And a colleague at MIT taught me a quote by an anonymous 19th century immigrant who said, "Before I came to America, I heard the streets were paved with gold. And then I arrived and I found they weren't paved at all. And then I learned that I was expected to pave them." And that really speaks to the Guastavino story, the talents that they brought to build these great buildings, and the incredible geometrical achievements that have gone largely unnoticed, like this remarkable staircase in St. John the Divine in New York, or the entrance hall of Carnegie Hall in New York City, where this is covered over with some plain white plaster. Maybe someday we could strip the plaster off so you could see the brick of the Guastavino family beneath. Or here in Washington, the National Shrine of the Immaculate Conception, an extraordinary example of their mosaic tile ceilings. Or the Army War College by McKim, Mead, and White, which uses Guastavino vaulting throughout. And in total, they built, we believe, more than 1,000 buildings coast to coast. We're still discovering their projects. This exhibition and our ongoing research uncovers several new projects each month. And I'd like to start this lecture. I was told I have about, to tell the whole story, I was told I have about 4 hours. So I hope the chairs are comfortable. The story really begins with this building, which Charles McKim called a palace for the people. This was the first great public library in a major American city, completed in 1895 in Boston. And the notion was very democratic, that any person on the street would have access to knowledge and books and newspapers. And this building is primarily built in the lower levels with Guastavino vaulting. And yet, 30 years ago, a 2-day symposium on the sisterhood between the cities of Barcelona and Boston celebrated Catalan culture and its influence on Boston. And they discussed music and literature and architecture. They discussed it under these vaults. And there was zero mention of Guastavino and the fact that the vaults overhead were essentially imported from Barcelona. So that gives you a sense of how little known it was and is. We know of Guastavino today largely because of the efforts of the art historian George Collins at Columbia, who wrote the first book in English on the great Catalan architect Antonio Gaudí. And he wrote the first scholarly work on the Guastavino Company, which is still the single best introduction to the field. It was published in 1968 in the Journal of the Society of Architectural Historians. It is almost 100% correct and is still very fresh, and it's a great starting point. So he was a giant, and he labored on the study of Guastavino, trying to identify their buildings, writing letters to different states in an age before the internet, trying to track down their hundreds of buildings. And sadly, he developed Alzheimer's and never finished his book project. So my book is dedicated to him. And he personally learned about the company in 1963. He found their telephone number. He called the company and he said, "Do you have any records of your work? Do you have drawings or letters or financial documents?" And they said, "Oh yeah, we have all that, but we just put it all in the dumpster." And so he called them at exactly the moment when the company was closing. And he said, "Don't empty the dumpster." And he jumped in his car and he drove from Manhattan up to Woburn, Massachusetts, and he loaded the archive from the company into his car and eventually got it donated to Columbia University's Avery Library, where it became the Guastavino Collins collection. The drawings that he saved from the dumpster, some of them are on display in our exhibition, and it was really his pioneering work that began the study of Guastavino, and so I wanted to say a few words about George Collins to start. We're in the Building Museum, so it's important to just briefly say, why is Guastavino vaulting different? On the lower image shows a Guastavino vault made of thin layers of brick built up in multiple layers, almost like plywood, applying different layers of thin ceramic tile. A traditional stone vault only stands when the centering, the formwork which supports it, the vault only carries its own weight when the keystone is placed, and then if you remove the centering, then the vault works. Guastavino vaults can be built with no support from below during construction, and so they were an extraordinary method of construction. And that minimal support made them very economical, but they were also heralded as a fireproof construction system adaptable to many different geometries. And I want to be very clear, the origins of the technology we are still uncovering, but it's very clear that it was originally a technology introduced by Moorish builders from the north of Africa into what is now the Iberian Peninsula, and we're still tracing it. But it's clear that it's a 14th century technology, almost like the microchip. It spreads throughout the Mediterranean. It becomes a widespread technique that you find all the way in Italy and Algeria and parts of France, but it's really most strongly centered in Catalonia and Valencia in what is now Spain. Guastavino studied in Spain. He studied not at the School of Architecture and not at the School of Engineering. He studied at the School of Master Builders. And that's something for us to think about today. His professors taught everything from drawing to foundation construction, mechanics, and his professors went on to found the School of Architecture in Barcelona, where Antonio Gaudí studied. So when Gaudí was a student, he visited Guastavino's works. And when Guastavino was only 25 years old, he won the commission to build an enormous factory that still stands today. It occupies 4 large city blocks of Barcelona in the city expansion called the Eixample. It was under construction in the 1860s, and here we see the 4 blocks that it filled with its enormous chimney, and it was a textile factory. It still stands today. It's known affectionately in Barcelona as the Rellotge because of the clock over the entrance that you see here. And you see Guastavino's working as an architect. He's building primarily in brick, but he also knows construction intimately and builds this enormously tall tower, which is 20 years before the Eiffel Tower, but has the elegant, graceful parabolic curve that the Eiffel Tower would make famous 20 years later. And this is an extraordinary structure for its time and a major landmark in the city of Barcelona today. This large hall still exists today. You can see the vaults that he built in the 1860s. You get a sense of the scale of these structures that he was building at only 25 years of age. We might reflect on the difficulties that young people in Spain face today in finding work, and you imagine what he was doing at his time. He was way ahead of his time in terms of providing natural light and natural ventilation to the workers, so you can see there were openings overhead. And these are the openings above ground, and by placing the working spaces below ground, they were also cooler in the summer. And so this was an extraordinary work of architecture at a major scale, and again is a landmark today. And he went on to do dozens of buildings in Barcelona. Some of them I've gone and visited, and I've occasionally seen one of the buildings is occupied by an office of architects, and I'll ring the buzzer and say, I'm an architectural historian, and I'm interested in the building, and they let me in, and I say, this is a work of Guastavino, and they all say, ¿Quién es Guastavino? Who is Guastavino? So even architects living and working in his buildings in Barcelona are unfamiliar with his work, and so we're trying to change that. His last great project in Catalonia was also his first major public space. This is a theater in the town of Vilassar de Dalt, north of Barcelona. This is an extraordinary dome, the dome really of a visionary. It's a structural vault. He built it in concentric rings like Brunelleschi's dome in Florence with no support from below. And this town today is so enthralled with the Guastavino story that they have founded a biannual Guastavino Prize for a young researcher. And they give a cash award and also a free trip to Catalonia. So if you're under 35 and want to do research on Guastavino, come see me. I'm on the jury, and one of my former students won, so it's completely rigged. In 1881, at the age of 40, having done dozens of major projects in Barcelona, perhaps he's restless, but he immigrates to the United States. He doesn't speak a word of English. He comes for professional reasons, perhaps bigger opportunities, major city expansion, an industrial age in America. He talked about the need for access to Portland cement. That's one part of the story. When Hollywood does the film, they will focus on the personal side of the story. He had some marital problems, and he came with the nanny to New York City with his youngest son, Raphael Jr., and his wife and other children went to Argentina. I won't speculate, but I'll just stop there. He arrived at an auspicious time when American cities were really susceptible to fire. This in Chicago in 1871, 19,000 buildings burned because of the wooden construction at the time. So there was great concern among developers, civic leaders about how to make buildings fireproof and about how to make cities safer. He tried to work as an architect. This is his oldest project in the United States, but he didn't really have the personal connections. He didn't speak the language. He hadn't gone to the right schools. He wasn't part of the right social circles. And so after about a decade here, he gets his break in the Boston Public Library. He gets a $90,000 contract to build the library. He founds a company which he calls the Guastavino Fireproof Construction Company. And here he is standing on an arch when the Boston Public Library is under construction. The arch is thin. He's confident. And it was seen as a real marvel of construction at the time, and so he was invited to lecture at MIT, which was nearby in Back Bay at the time. You can see these vaults, these four vaults we know from construction photos were built in only 4 days and were remarkably strong. Charles McKim, the architect, demanded a load test, and Guastavino loaded the vaults with 500 pounds per square foot, which any engineers here know is quite a substantial load. And these vaults today are a signature feature of the library. But another important thing happened in this project. In Spain, all of Guastavino's projects were covered with plaster. And in the Boston Public Library, he and McKim arrived at the idea to strip off the plaster and expose the brick, be honest with the construction, and that really began decorative possibilities in Guastavino construction. Charles McKim certified that they had their entire confidence in the system, and within a couple of years, Guastavino is building dozens of buildings for McKim and others. And I want to focus on one very important point. At this period in American architecture, the designers of buildings, the architects, would produce a small number of drawings. And I found in my research that many times they would write Guastavino here. In other words, they trusted the craftsman to come and do a good job and develop the geometry and develop a finish. So here we see two alternatives that Guastavino developed. Only he knew how to build them, knew how to make them economical, and knew how to make them strong and stable. And so it's fascinating that in our research we find over and over again that the Guastavino company and Guastavino Sr. and his son were really the authors of these spaces. You see this one under construction. And immediately in 1891, they're advertising all of the projects they're working on, many of them with McKim, Mead, and White, projects including, for example, Thomas Edison's first power plant, the Pearl Street plant in New York City. So he lectures at MIT in 1889, he publishes the book, and then at the Centennial, the Columbian Expo in Chicago, the keynote lecture at the Congress of Architects is delivered by Rafael Guastavino. And so he had really achieved a level of success at that time. And he proved his projects would work by doing load tests. Here you see an arch with 112,000 pounds piled on top of it. And in this way, he gained the confidence of cities and clients. He also did fireproof tests. He's the second from the left in this photo. He would build a vault and set a fire under it and let it burn for 2 days, and then load on top and show that it was perfectly stable, and that was enough to prove to the New York Building Department that his vaults were stable. He built a factory in Woburn, Massachusetts that allowed them to fabricate tiles of different shapes and colors. So within about 15 years of the Boston Public Library, they're suddenly doing things like this. This is New York City's first subway station. They can begin to do polychromatic decorative possibilities as well as structural possibilities. And this is one of the greatest public spaces in New York City, but sadly it's been closed to the public for about 60 years. And it was a period in history when the notion that we would travel underground was a little bit frightening to the public. We thought we would, some of the quotes of the time said, I don't want to be treated like a rat scurrying underground. And so Guastavino built what the New York Times called an underground cathedral with chandeliers, with skylights. And this station is in beautiful condition today and hopefully will one day be reopened and open to the public once again. The connection with McKim led to projects like the Army War College, Roosevelt Hall here in Washington, where the Guastavino dome, there's a double dome and a series of beautiful coffers as well as barrel vaulted or groin vaulted ceilings. And the Biltmore Estate in Asheville, North Carolina, with Richard Morris Hunt came, I believe, from the lecture he gave in Chicago at the Expo. And although you find Guastavino vaulting throughout the Biltmore, the 1 million tourists a year who visit it, until we can get the Archivist of the United States to tell them that they should look up. Unfortunately, we're still fighting an uphill battle to get Guastavino as part of the tour. He was so taken by North Carolina that he built an estate down there, a kind of Biltmore of his own. He called Rhododendron. This is a rare photo we have of him where he composed music and wrote, and a visitor wrote this little ode to Guastavino saying, "Give me a dish of Mr. Guastavino's paella and a bottle or two of his own pleasant wine." So picture this transplant from Spain making paella and making wine in the mountains of North Carolina. That original quote we have in the exhibition. And one of the father's last great projects was the Basilica of St. Lawrence in Asheville with an incredible dome, and he's buried there. He paid for this church. Our research recently uncovered new drawings of this project, and we have a number of artifacts in the exhibition. And when he passed away in 1908, rather unexpectedly, his obituary called him the inventor of the subway arch. And in Spain, the obituary said he was a genius inventor among the Yankees. But his son continued the company with the same name, almost with no pause or break, and immediately the son is building one of the greatest projects they ever built, which was the large dome over St. John the Divine. The crossing arches were in place, and they didn't know how to put a temporary closing over the dome. And much like Brunelleschi several centuries earlier in Florence, Guastavino Jr. said, I know how to do this, and they built it in 14 weeks for $10,000. They built it with no support from below, and you can see that the masons are sitting on top of the tile that they've laid the day before. and they're closing it in, and crowds were gathering on the streets of New York to watch this marvel of construction. Scientific American devoted a large article to the marvel of its construction, and although it was temporary at the time, it's still there a century later and should be there 5 centuries from now. If we look at the cross-section of the Guastavino Dome compared to the great domes of the world, like the Pantheon in Rome or the Hagia Sophia in Istanbul, you see that the Guastavino Dome is only about 4 inches thick. It's 3 tiles thick. In fact, if you take the ratio of the thickness of the dome to the span, it's twice as thin as an eggshell. So picture taking half the thickness away from an eggshell and then building it at that scale and standing on top of it while it's under construction, and that gives you a sense of their abilities. And here's Rafael Guastavino Jr. Now, I should point out that within the Guastavino family, the father is called Rafael Guastavino II, and the son is called Rafael Guastavino III. And I just want to be very clear here in Washington that the original RG3 is Rafael Guastavino III. And a lot of my research and work has been trying to emphasize the important work of the son, who's largely been overshadowed because oftentimes Rafael Guastavino has been a single name, often referred to the father, but in fact most of the major projects were completed in the period of by the son. And here he is in the 1920s at his mansion on Long Island. He becomes a millionaire, races yachts on Long Island Sound, is very successful. And he's particularly adept at building large domes with minimal formworker support. So about 1910, he's building major domes up and down the East Coast. In fact, in 1910, I discovered that at a single time, they were building 100 buildings up and down the East Coast, major domes in Philadelphia, Washington, New York, Boston. Absolutely extraordinary. They had offices in 12 cities. And one of their most important domes is here at what is now the Museum of Natural History, the Smithsonian. At the time, it was called the National Museum. And you see the dome overhead has decorative Guastavino tile work within it, and the elephant in the rotunda is supported by the ceiling of the Baird Auditorium that we'll see in a moment. Above the dome, there's a double dome, a thin shell by the Guastavino Company, and the inner dome is made stable by these flying buttresses. And you can almost think of the Guastavino family as master masons dropped into 19th century America from centuries earlier. So these are Gothic flying buttresses. This is Gothic technology supporting some of our most important landmarks here in the United States. And this is an extraordinary space and is very well looked after by the Smithsonian. And below that enormous elephant is this incredible auditorium, the Baird Auditorium, which is one of their most remarkable projects. I urge you to go see it. And while you're there, you should listen to the lecture. Occasionally, there's a lecture there on Guastavino. So, and you see this is about a 90-foot span. As a structure, it's incredibly shallow and really shows the aesthetic possibilities of their vaulting, but also the structural possibilities. Here we see a construction photo where these wooden guides basically serve as geometrical guides to help the masons know where to build to, but they're not supporting much load. The vault is basically self-supporting during construction. And the decorative terracotta within the ring of this auditorium is absolutely extraordinary. We have much more research to do on the interrelations with terracotta companies and other craftsmen that they worked with. And we also have other examples of domes here in Washington. This is a slide from an image from the architect of the Capitol. Within the House and Senate office buildings, you find shallow Guastavino vaults. That was this vault under construction. And at the National Academy of Sciences in Washington, also under construction. So right around the mall, there are a number of significant projects. And I just want to pause for a moment to acknowledge the vaults in this significant building that we're in, which was originally the Pension Building. And this is a photo of these vaults on the sides here of the pension building by Montgomery Meigs. And I want to point out that these vaults were built in concentric rings with brick, which I believe was done with minimal formwork. The piece of wood defines the radius of the vaults, and this was done in the 1880s, and the mortar would have held each brick in place by the adhesion of the mortar, allowing the masons to build it in concentric rings. I hope someday to be able to build maybe a half-scale version of this here in the National Building Museum, if Mr. Wren gives me permission. And I want to point out that this was right at the time after Guastavino had arrived in this country, but he wasn't yet very well known. And it's an interesting thing to think about whether he could possibly have been engaged in this or what was available to Meigs in terms of fireproof construction technology at the time. And I think there's more research to be done on these vaults, and so I just wanted to make a parallel with those domes. Also, in the Supreme Court building over the stair, there's a Guastavino vault, and we're constantly discovering new ones. This is the one dramatic example of tile ceiling in the National Archives building, where I was absolutely overjoyed to get an invitation from the Archivist of the United States to come to his office, and I was blown away when he had plans prepared and historical documents for us to look at, and then the ultimate gift, an actual Guastavino tile. This is kind of the ultimate present, and so I'm very grateful for that. And we went on a mystery hunt trying to find the vaults in the National Archive building by Pope, and we thought initially maybe these coffered ceilings were by Guastavino, and we found some acoustical stone by Guastavino in the walls, and I was absolutely delighted that the Archivist of the United States is not afraid to roll up his sleeves and get dirty. And so we went looking for these ceilings and walls, and we went up above the domes, and we found that the major domes, this shows your dedication if you're willing to go to high spaces and in search of them. And the spaces aren't always clean, but we found the major domes there were not by Guastavino, but absolutely extraordinary adventure. And then we came out on the roof with this incredible view of the Guastavino dome, which was really introduced in the National Museum by the architects McKim, Mead, and White, who were consultants, and they brought Guastavino with him. And so even though we didn't find a big dome there, we found an incredible view of a Guastavino dome. And you have to remind yourself not to get too close to the edge, even though you may be excited to go and see it. And so for any young people who are trying to decide what to dedicate your life to, I just want to be very clear that who knows where Guastavino will take you. And that was absolutely extraordinary, one thing I will remember my whole life. So I thank you, sir, very much for that adventure. And you were kind enough to blog about it as well. So back to the main story. This was a period in American history when architects and planners were interested in creating grand public spaces. This was a covered market in New York City. This is the underside of a bridge, the 59th Street Bridge. So the notion that the underside of a bridge could be an attractive public space, and today it's one of the most extraordinary spaces to purchase fruit that you can find. This is the Food Emporium at 59th Street under the Queensboro Bridge. This space, New York City housed maintenance trucks and snowplows in for decades, and it's recently been redeveloped thanks to far-sighted developers who recognize that these ceilings have value. The Oyster Bar, of course, is a century old, but it had acoustical problems, and that led the company to work with Wallace Sabine, an acoustical scientist, a physicist at Harvard. They developed some of the very earliest acoustical materials, and that really led to new possibilities and major train stations with acoustical finishes. This is a station in Buffalo, which is abandoned today, and the company contributed the ability to build ceilings that were not only load-bearing, not only fireproof, but also could absorb sound and could quiet the spaces of busy train stations. And the decorative possibilities that they extended to probably their greatest decorative project was the Nebraska State Capitol building. And here you can see the mosaic ceilings, were a collaboration with the mosaic artist Hildreth Mier, whose work was showcased here at the National Building Museum. And she developed cartoons, she developed sketches and drawings for her designs, and then she worked very closely with, I can say RG3, and you know who I'm talking about. And he painstakingly developed the tiles, the shape, the colors, and many different representations of American life and Nebraska life. There's something like 5,000 representations of corn in this building. So this is a true American state capitol building. And just a brief tribute to this project with Mier, you can see the complexity of the mosaics, the detail that the Guastavino Company executed in working closely with her. And again, it's appropriate that we're at the National Building Museum following on from that marvelous exhibition. Now, I want to say something else very important, not just about the decorative possibilities, but what they contributed was unique in the history of American architecture in terms of a single company who provided all of these services. And this gives you a sense of the beauty that was possible. This project they made more tiles for than any other project. They made hundreds of thousands of tiles for this single project. And it's really extraordinary. So if you can get to Lincoln to see this, I strongly recommend you do. And the good thing is at Lincoln, if you go in and ask about Guastavino, they know who he is. And that project is really only possible because of a project here in Washington, the National Academy of Sciences, together with the architect Bertram Goodhue and with Hildreth Mier. But you can see in the case of the project here in Washington, the Guastavino ceiling was built first in acoustical tile, and then the mosaic was added in plaster and paint afterwards. And it's recently been cleaned and restored, and absolutely beautifully restored. We highlight the project in the exhibition, and you can go and see it here in Washington. These are some images from the cleaning, and this image really shows you the Guastavino tile and then the mosaic applied on top of it, whereas the Nebraska State Capitol building a few years later, they were able to bring together the tile and the mosaic. So although we know from the Guastavino family records that this project, the Nebraska project, nearly killed RG3 because it was so intense. Now I want to highlight that the Guastavino family is alive and well, and they actually live in the eastern shore of Maryland. And the young woman on my right is Helen Guastavino, who's the daughter-in-law of RG3, and on her left is RG5. And they are here with us tonight in the front row. So welcome to the Guastavino family. They've been tremendous supporters of Guastavino, and even though it's my understanding that George Collins in his research at one point asked to borrow the unused ticket for the Titanic that the son had when he was sailing back and he missed the boat, and that ticket's worth a lot. And unfortunately, I think it never made it back to the family. So they would be right to be skeptical of academics asking to borrow artifacts. But they've been very generous in loaning drawings for the exhibition, and we've learned a lot from them. And a couple of hours ago, we had an extraordinary moment in history when I was showing the Guastavino family through the exhibition, and we were standing over the display case that showcased the National Academy of Sciences and had cartoons by Hildreth Mier. And Hildreth Mier's granddaughter walked up and said, "Oh, I want to see my grandmother's drawings." And so here we were a couple of hours ago with Raphael Guastavino V, and on his right, Hildreth Mier's granddaughter. So that was an extremely exciting moment for us, for me, and we're thrilled to bring these families back together again. The production of tiles at the company really is a history of the 20th century in America. You can see the World War, you can see the Depression, you can see World War II, but you can see that the company really peaked around 1910 and the 19-teens when they were making almost 1 million tiles a year, and really were extraordinarily productive. Eventually, the son retired in 1940. He passed away in 1950, and they began to face competition from concrete builders who were learning how to make shells in reinforced concrete. They were building planetaria, and I found in my research that the Guastavino vaults were often less expensive than the concrete shells, but architects into the 30s and 40s liked the idea of modern materials like steel and concrete and not brick, and so even though the Guastavino vaults were faster to build and less expensive, they were sometimes beaten out by concrete. So eventually the company closed as the cost of labor went up, architectural style changed with the rise of modernism and the desire for straight lines, and Guastavino III retired, and it was really seen as a historical system, yet they were building things like Art Deco skyscraper lobbies in New York in the 1920s and trying to convince architects that they were the modern trend. But I want to point out that in this cross-section, you can see a reinforced concrete slab and beams, and the Guastavino vaulting is almost like a decorative ceiling below. It's supporting its own weight, but it's no longer supporting the floors above. So with the rise of engineering and the inability to calculate the loads in Guastavino vaults, they were kind of sidelined and became almost a decorative finish. The company succeeded because they were constantly innovating. The father and son had 25 U.S. patents. The son had 4 U.S. patents before he was 19 years old. I tell my MIT students that's a good start. They controlled the entire process from extraction of the clay to installation. They worked closely with leading architects like McKim, Mead & White or Cass Gilbert. Their construction system at very high load capacity was versatile and fireproof, and they also benefited from the business skills of a father and son team, the Blodgett family, who really made their company solvent because Guastavino Sr. in particular was extremely unstable financially from what we understand. Here's an example of one of their patents, a keyed tile, and then you see it actually in the construction at the Boston Public Library. So they're constantly bringing their innovations into construction. And I argue that their work is among the most daring, structurally daring masonry built of all time. Some of the most extraordinary, compressive, load-bearing structures ever built. The decorative possibilities are unique in the history of American building art, and we have Hildreth Mayer to thank for much of that collaboration, and she was really the driving force. And they worked closely and developed personal styles with different architects, and their work is in many of the country's most significant buildings, but we're constantly struggling to document them. This staircase at Carnegie Mellon, which is housed in the School of Civil Engineering, is one of the most extraordinary structures I've ever seen. It's very difficult to calculate and prove that it works, but it's been standing and supporting loads for 100 years, and we need to study and understand their works in order to better appreciate their historical importance, but also to help preserve them. And there are constant challenges. These buildings are being torn down, replaced, or damaged. When I first arrived in Boston, I was going out looking for projects one by one, and I knew of an 8-story spiral Guastavino staircase right next to the Boston Public Library on Exeter Street. And I'm following the address, and I go there, and I arrive there, and I see the building, and missing off the front of the building is an 8-story imprint of a staircase that they've just torn down the day before. I missed it by one day. And, you know, what a learning opportunity that would have been to at least document it before it was torn down. We still don't have a good understanding about how they work. We're doing a lot of research to develop calculation methods to prove that they're safe. And their projects, unfortunately, many of them have been really disrespected. This is a Cass Gilbert building at the St. Louis World's Fair in 1901. I think of this project as a kind of prototype for Ellis Island. It's a similar geometry, a very significant Guastavino project, and sadly in the mid-20th century a crack appeared, a tile fell, and they got very concerned, and they applied steel on the underside and sprayed the entire underside with concrete. So you can no longer see the Guastavino tiles, and that's irreversible. So we're constantly trying to understand the kinds of things that can go wrong and show best practices for repair. Worse than that, though, the Metropolitan Museum of Art in the 1960s were trying to figure out if the Guastavino vaults were strong enough to carry a new exhibition piece, a new piece of sculpture. And the engineers on the project weren't able to calculate it, and a brilliant young engineer said, well, we can't calculate it, but let's do a load test. And they loaded it up to twice the load capacity that was going to be needed. But because he couldn't prove it with a calculation, his boss didn't accept the result of the load test, and they tore down the vaults in the Metropolitan Museum of Art, which is obviously a waste of money, a loss of architectural heritage, and a tragedy for architectural history. But there's better news. The Plymouth Rock portico has just been beautifully restored by the National Park Service, working with Robert Silman Associates, who are really the premier engineering company who've done a lot of tremendous work on Guastavino vaults, including the Oyster Bar in Grand Central after it had a fire. Bob Silman, who's here tonight and is an enlightened engineer who appreciates the value of history, he went to that 1901 building test that showed that it was capable of standing even after the fire, to prove that the Oyster Bar vaults were still strong enough, and was able to use that to help justify their safety. That's beautifully restored and has undergone another recent cleaning and restoration. And at MIT, we're trying to document their buildings. We've created a searchable map, so you can load it on your smartphone when you're walking down the street in Albany, New York, or Cleveland, Ohio, or Washington, and look for projects near you. We want to share resources, but we're also trying to discover their works. And I have an ongoing offer that if any of you find a building by Guastavino that I don't know about, I will invite you to lunch. And there are a lot of graduate students at MIT, and there's nothing like sending hungry students out on the street to help discover new buildings. So we discover several new buildings a month, and recently the mother of one of my students in Portland, Oregon, she called me and said, I've got one. I said, you've got one? What? A Guastavino building, a beautiful synagogue in Portland. And I thought, that's really not possible, but okay. And I happened to be out there a few months later, and I confirmed that, in fact, there was a large Guastavino dome in a synagogue in Portland, Oregon that we knew nothing about. And just to give you a sense of how much we're still discovering, when this show opened, a longtime supporter of the National Building Museum, Bob Oshel, came through the show, and he sent me an email, and he said, I think my high school in Topeka, Kansas, had this ceiling in it. And he sent me an image and a link to it, an enormous auditorium in Topeka, a beautiful project, a really important project that we have zero records about. And so that shows you how much we still have to learn and contribute. And with the support of the National Endowment for the Humanities, who made this exhibition possible, we're really trying to activate the American public in the search for their buildings, both out of intellectual interest and the good of your heart, but I'm going to add more and say for a free lunch. So Bob and Kay joined me for lunch today, and I was able to repay the debt at Clyde's, just a few blocks away, to thank them for teaching me about the ceiling in Topeka, Kansas. And that really gives you a sense of how much we still have to learn and discover. So thank you to Bob. Now, I just want to end by telling you a little bit about our exhibition and encouraging you to go see it afterwards. And in particular, I want to highlight the construction of the vault that you see in the lower right, which is a half-scale model of a vault, of this vault, in the Boston Public Library. And so this design and construction was developed by students at MIT working closely with masons, professional masons from the International Masonry Institute, IMI, and bricklayers and allied craft workers, BAC. And so here we see the construction of this vault here at the museum. And I want to be very clear, if there's any doubt about it, the MIT students learned a whole lot more from the Masons than the Masons learned from the MIT students. And MIT's motto is mind and hand, and it was a beautiful example of the value of working with your hands and learning by doing. So you can see this vault under construction. They wouldn't let me pick up a trowel, so I was just moving tiles around wherever they wanted it. But that was a real joy for the whole team, and we're incredibly indebted to the masons who made this possible, built this beautiful piece, and we learned a lot, because one of the hallmarks of the Guastavino Company's work is this herringbone pattern, and we had never tried to do that on a doubly curved surface, and let me tell you, it was not easy. And Bob Arnold in particular, who's here from IMI, really pioneered our understanding of how to redo that. And the resulting vault with a mirror underneath, it's left unfinished in the middle. The idea was to make almost like an anatomical dissection, so you could see the layers and you could see that it was self-supporting even if it wasn't closed in, is really a tribute to the skills of the masons, and we're absolutely delighted to have worked with them on this, and we look forward to building more. The exhibition includes a flock overhead to try to encourage people to look up and see the ceilings. It includes original artifacts and drawings. It was a collaboration with a large curatorial team, and the NEH really supported us at every step in funding the planning of the exhibition, and so I want to acknowledge and thank all of the members of the curatorial team. And especially here at the National Building Museum, it's absolutely incredible, the support we've gotten. And I just want to highlight, for example, Hank Griffith, who, when we said we're going to come in and build a vault, he didn't flinch. He said, great, when do we start? And you can imagine not all institutions would be happy to have you lugging water and mortar, and so it was really in the spirit of the National Building Museum, and especially my colleague Chrysanthi Broikos, who really made it all possible. We had a tremendous design team, and we learned a lot throughout. And again, this vault was a really important moment for us. But I'll say a little bit more at the end and acknowledging it, but now I'd like to shift gears and just talk a little bit about what we still have to learn from Guastavino vaulting and what's the future of it. So in the remaining 3 hours that I have, I'm just going to go through a few other projects. I was introduced to this in Spain on a Fulbright scholarship. I learned to build vaults at a workshop there, and then eventually a student of mine at MIT, Michael Ramage, we built a similar vault at MIT, and we proved that even though this was a 1/2 inch thick and had no steel, if you build the right shape, it's very strong. And for the MIT alums in the audience, this is a span of about 2 smooths, and this is about an MIT ton on top. And we were approached by a client in England who said, I want to make a building with a 500-year design life, and I want it to use zero energy and have non-toxic materials and employ local people, and we think Guastavino ceilings would be the perfect solution to it. So we developed a system, calculation methods for building 2 shallow domes out of Guastavino tile. This is, as far as we know, the first Guastavino vault to be built in the United Kingdom. And MIT students, including Wanda Lau, who's here tonight, helped calculate and prove that these domes were stable. And we brought masons from Spain to help train English masons, and that was an incredibly fun project. This mason that you see in the sunglasses only knew 3 words of English, and he would walk around the site saying them over and over again, and those 3 words were, I love you. And so that made for a very congenial work site, although the Spanish mason said to me afterwards, you know, these English masons are so strange. And I said, well, why do you say that? I was translating between the groups. He said, well, they don't sing while they work. You know, the Spanish masons were belting out opera while they were laying brick. And so that was a great project for us. And you can see a series of long span domes, unreinforced, so not putting steel in them. The steel will corrode over time, so we don't put steel in them. This is like a Gothic vault, and we have natural light and natural ventilation like that factory in Barcelona. The walls are made of rammed earth, of local soil, so you dramatically reduce the carbon emissions by using local material. It looks like concrete, but it has much lower embodied energy and is much better for the planet, and essentially when this building is no longer occupied, it'll return to the land. The tiles are made from the local clay as well. The roof has a green roof. I asked the client not to drive a riding lawnmower on top because it didn't seem like a good idea, And he thought for a minute, and he said, well, there's a neighbor who has about 50 sheep. Maybe they could come up once a month and graze on top of the roof. And I said, that's absolutely perfect, and they'll fertilize the roof too. So this is a truly sustainable project. It's won a number of international awards for sustainability. And in our calculations, it pushed the limits of what we were able to show was safe in terms of its span and its rise. That's the key relationship. And the shallower it is, the more daring it is. In our research on Guastavino, we found a project at Yale that's twice as shallow. It spans 45 feet and is 30 inches in rise with no steel, and you see these two domes on top of each other. So I hope Yale University never calls me to say, can you prove the safety of this ceiling? It's been there for a century, but it just shows you what they achieved. We still struggle to be able to prove today. And then that project led to another project in South Africa where we train local workers to build vaults out of soil, compressed soil bricks, very low carbon energy, low carbon construction system with no steel. We find the shape of the vaults that will work in pure compression. And this is essentially a masonry city in the bush in South Africa at a World Heritage Site, working with a really incredible architect, Peter Rich. And to our tremendous surprise, a couple of years ago in Barcelona at the World Architecture Festival, out of 700 buildings that were entered by Norman Foster and many of the world's great architects, this building was the grand prize winner and was named World Building of the Year out of 700 buildings. So that gives you a sense that Guastavino vaulting is still alive, has a bright future. We're still learning from it. And this exhibition has been a perfect opportunity to continue that process. And I'll close with the last few projects. This is every year we like to build at least one vault. So when I was in Rome for the year in my studio, I built a half of a bay of the American Academy vault that you see on the left. On the right is the Boston Public Library, also by McKim, Mead & White. And so this is my office in Rome. Seemed like a good way to spend time. So in 3 days, we built a shallow vault, half of a vault, and we invited people to come check it out. And it's about 1 inch thick. And this is a piece I call Two Bald Guys and a Hairy Guy. So you see these vaults have a lot of load capacity and even more load capacity. And we also built a vault in the Cooper Hewitt Museum for the Design Triennial in New York a couple of years ago. This was made out of 100% recycled content bricks, and then a student, Philippe Bloch, who's now in Zurich teaching, built a freeform vault there in 2011. So every year we've built one interesting vault, and last year in Boston we built the vault for the exhibition, and then we built it in Washington, and from here our plan is basically world domination. We're going to New York City next, to the Museum of the City of New York, and then to Barcelona, we hope, after that, and then to other cities near you. So we're going to keep spreading the gospel of Guastavino and trying to make sure that people know about it. We're going to try to convert you one at a time. And I was so delighted that the Archivist of the United States is now a card-carrying certified Guastafarian, and to have him here tonight was really special for me, and I hope some of you have become Guastafarians as well. Some of you already are, and I want to end by saying that the Boston Public Library, that 30 years ago did not know the story from Barcelona that built these ceilings, has recently decided to rename this space the Guastavino Room. So we're making progress. And I have to end by thanking the generosity of the sponsors who've made all of this possible, and has really been an incredible team effort, and many of them are here tonight. And also, the new color photography is by an extraordinary photographer from London named Michael Freeman, who went and photographed 42 Guastavino projects, creating new color photography that we have in the exhibition and in the book. And just to give you a little sense of Michael's character, this is the Vanderbilt Hotel in New York, which is today a steakhouse on Park Avenue. And when he went there to shoot it, Michael asked the bartender to make him a martini. And he did his photography, and then he enjoyed the martini afterwards. And his photography really brings the project to life. So I want to thank him. And I want to end by thanking, in particular, my colleague Maggie Redfern, who's the project manager, who's here tonight. And she has made the whole project run on time and actually ahead of schedule. And most of that is despite my best efforts to derail the project. She has kept it all on track. So I thank you, Maggie. And again, we just couldn't be more excited to be here at the National Building Museum and to have a crowd like this tonight in this space celebrating the work of an immigrant family who created some of the greatest palaces for the American people is truly a special event. So thank you all very much for being here. Thank you.
Just a quick question. What kind of response to earthquakes? How did earthquakes treat these structures? Seem to be pretty stable.
Yeah, how do the vaults work in earthquakes? The short answer is that they're quite lightweight, and so for that reason they've done better than traditional masonry vaults that are 3 or 4 times thicker and therefore much heavier, and therefore the earthquake forces are higher. They have a number of projects in California, including some significant projects in San Francisco that have survived multiple earthquakes. And so when we build new projects, we tend not to build them in seismic zones, just for reasons of liability. We think it's not a great idea. Minor seismic or moderate, okay. So in short, the masonry is brittle, is not very strong in tension, and the building code says it has 0 capacity for earthquakes. But of course, we have examples of great vaults and domes in history that have survived earthquakes for millennia, like the case of the Pantheon in Rome. But in general, unreinforced masonry, and I'll just add that some of you may recall the great earthquake of Virginia of 2012, which we felt at MIT and in Boston. And I recently went down to the University of Virginia, where the Rotunda Dome, Jefferson's Dome, is of course by Guastavino. After it burned, it was rebuilt by McKim, Mead, and White, and Cabell Hall at University of Virginia. And some minor cracking occurred, but we don't think there were a lot of new cracks because of the earthquake, and that was quite close to the epicenter. So the short answer is active area of ongoing research, but the buildings have done remarkably well when they have been subjected to earthquakes.
Very flat domes, do they need the tension ring?
Yes. You must.
So how you do the tension ring without steel?
Are you an engineer or a mason?
Yes, I am.
So the question is, at the base of a dome, when you have the outward thrust, do you need a tension ring in steel? And this goes on. Yes, they did include tension rings in Guastavino projects. They most often did it with steel plates or steel bands or sometimes angle sections that were done around the base. It's a major concern for the preservation of Guastavino vaults that any tension ring at the base is located and that its condition is checked. And in the project that we did, the vaults that I showed you, in the vaults proper that we built in England and in South Africa, we use no steel in the vaults, but in England, embedded within the concrete and with a very generous layer of cover in the concrete to protect the steel, there is in fact a steel tension ring. Because that dome is so shallow, it has a very high horizontal thrust. Very keen observation, sir. Thank you for clarifying that.
Hi. Is there any similarities between Guastavino's style and Sinan the architects that you know of?
Did you say Sinan?
Sinan, the architect who built the Hagia Sophia.
Yeah. He was an Ottoman architect who was practicing a little bit after the Hagia Sophia, but in general, what we know is that Guastavino Sr. in his studies studied the great buildings of the past, including the Hagia Sophia and other domes in Istanbul. He reproduced them in his book in section and elevation, and he learned from that. So he really saw himself as part of a long tradition of construction and masonry. And although he hadn't traveled to visit those buildings in person, as far as we know, he was familiar with large vaults and domes in and near Valencia and Barcelona, and he visited those. So he was learning from precedents, but we don't know of a direct link with the Ottoman Empire or the Hagia Sophia. Thank you. Yes, I think here.
Hi. I have probably the smallest Guastavino tile building in the world. I have a 200 square foot visitor center on Roosevelt Island that was the trolley car entrance to next to the Queensboro Bridge with a Guastavino ceiling. The building's been moved 3 times. The ceiling is perfect. And I also have a Guastavino tile that we found when we restored it. So you're welcome. Anyone's welcome to come visit it. The ceiling is absolutely perfect, and it's 103 years old.
That is wonderful. Thank you so much. And I knew that there was a vault on Roosevelt Island, but I have not been there to see that. So it's very good to meet you and to learn of that. And my distinguished colleague Maggie, I'm sure, is aware of that, but also always taking notes and on the lookout for projects to make sure we have them properly noted on the map, because when you dedicate your weekend to Guastavino hunting, as we hope you all will do, we don't want to send you astray. So, and also, I should add that we're actively working with support, in particular, of Catalan sponsors to create an expanded version of our website so that the map becomes a wiki map that you can click on your vault or a vault that you think should be there, and you can submit photos or upload documents or archival information. So this is really part of activating everybody, because we know the work of documenting the Guastavino Company's work, as George Collins discovered, is greater than the work of any one person. So thank you very much. Time for just one or two more, and okay, last one.
Okay. I wanted to ask, if one were a builder here in the United States wishing to emulate something like a Guastavino vault, what type of reception could we expect from, let's say, building code authorities?
Very good question, and I'll tell you how we've done all of our projects that we've actually built and passed inspection by building code authorities. What we've always done is worked very closely with a local builder who's going to build it. In your case, that may be you. A local engineer. And in almost every case, we've built a small-scale demonstration project first, kind of on the scale of the vault that we have here in the exhibition. So we build it, everybody sees the process, everyone gets on board, and then we put, 10,000 pounds on top, and people say, okay, that looks pretty good. And obviously we develop calculations as well, but we find that the act of actually building a model version is a way of getting everybody to have confidence in the system. And we found that building authorities have been quite receptive if we engage them from the beginning. And we were quite nervous with the project in England, but the building inspection, the guy came in, he looked around, he looked up, he looked back down, and that was it. So so it's certainly possible, but it is important to work with enlightened engineers who believe that an arch with no steel in it can stand up. And many of those exist in the United States, and their ranks are growing all the time, we hope, through efforts like this. So, and I have students who are always wanting to build. So, I think the potential is bright. So if any of you, the future is bright. So if any of you are looking for a new wine cellar, James may be able to help you build it. Some of the other masons may be here. And you could hardly have anything more beautiful and durable in your home than a copycat Guastavino ceiling. And so we hope that more will be built. And again, I just want to thank everyone for coming. And I want to make sure I'm clear that the exhibition is open right now. Yes, so please do have a look at the exhibition. And there are a few shopping days left until Memorial Day. So if you haven't finished your shopping, there is a book available, and again, I want to thank very much the National Building Museum for hosting this and for making this exhibition what it is, and this event what it is, I just couldn't be more pleased to see so many people here. And I ask you to carry forth the banner of the Guastafarian tribe. Thank you.